Hello guys, I am Ali Jawad and welcome to my YouTube channel. This is lesson number 3 of chapter number 9, Transfer of Heat of syllabus Physics 5054 for Cambridge and O-level students. To understand the topic in detail, please watch lesson number 2 and lesson number 1. I am providing the link of these lessons over here. So in our lesson number 1 and lesson number 2, we have discussed about the transfer of heats in solid and what happens at the molecular level when the heat is allowed to pass through solid, how the molecules and atoms and electrons behave. So to know all of this, please watch lesson number 1. In today's video, we will start with the second type of transfer of heat, that is convection. This type of transfer of heat is associated with the liquids and gases. So in this video, we will learn convection in liquids and convection in gases separately. So let us continue with that. Convection takes place in liquid and gases, and molecular motion is associated with it. In this type of heat transfer, the molecular motion is not like the vibrations of molecule as we have studied in convection. In this type of movement, the molecule is not fixed at the particular position. The molecule moves here and there along with its energy to transfer the energy from one part of the container to another. Along with the convection, there is a density difference which is created because of the heat. We will learn that how the density difference create the conventional current. So as you can see in the figure below, the liquid has a crystal of potassium permanganate, and when it is heated, the potassium permanganate is rising. On the second picture, in the second picture, you can observe that the smoke is rising from the candle to the top and it is leaving the container. So when we heat a liquid, the molecules at the bottom absorbs heat energy. That heat energy causes them to move far apart. And when the molecules move far apart, the density decreases because the volume is increasing. As we can see from the formula of density is mass over volume. So because of the expansion, volume increases, and because of this, density decreases. So the local density at this particular position of the liquid has decreased, while this region has a higher density because in that region the molecules are near to one another. So the density difference is created, and the lower density molecules tries to move upward while the heavier ones try to sink. This creates the movement of liquid, which is known as conventional current. The hot molecules starts to rise like this, and the cold molecule sinks. As you can see in this image, the hot bubbles of liquid are rising while the colder ones are sinking towards the bottom of the container. This enables the heat to be distributed in the whole medium. As in the case of gases, the convective heat transfer takes place more or less similar to that of liquid. This apparatus is used to give an evidence that convection occurs in gases. So what happens in this experiment? We take a container which has two cylindrical outlets, and a bit below one of the cylindrical container, we can place a burning candle. The burning candle heat up the air molecule at that position, and because of it, the air molecules rises and escapes from the container. That causes a low pressure to be generated at the candle's end. Now, if we may place a burning matchstick or wood at this point, the smoke of the matchsticks move downward instead of moving in the upward direction. And why it is so? Because of the escape of air molecules, the low pressure is created, and low pressure is acting as a vacuum, and the smoke is being sucked in. So the smoke travels from this point, from high pressure region to the low pressure region. And from this low pressure region, it again gets heat. And when it gets heat, so higher energy molecules try to escape again from the container, and the smoke moves like this. So this apparatus can be used to produce an evidence which tells us that heat transfer takes place in gases through convective mechanism. Thank you for watching the lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you.